Hello everyone, this is Omendra Bharat. I teach physics to the aspirants of IIT JEE and NEET in India, and I also teach physics to the students abroad. And that I do with the help of my app PHYOMS, PHYOMS. It is available on Google Play Store as well as on your Apple Play Store. You can download directly from there. And I also give the classes, the live classes and the online classes with the help of Skype also. Today I am going to show you one lecture, one example I am taking from the assignment of one of my students in US. The question is on the principle of conservation of linear momentum. So let's come up to the question directly. One thing I want to add here that either with my app PHYOMS, PHYOMS, or with the help of Skype, I simply share my screen to the students, and then whatever I write here with this digital pen on my laptop is simply visible to the students on the other side, and it becomes for me also, it's a very simple way of teaching, and for them it is very simple way of studying. So let's discuss the question. So now we are on the Skype, and first let me share the screen to the student side. And now, here is the question. Okay, the question says like, there are two masses, there are two particles, number one is M1, other is M2, and they attract each other with a force that varies inversely with the cube of their separation. Means they are talking about a new force, let me write it like something, F is directly proportional to 1 upon x cube, or you can say it is inversely proportional to the x cube, where x is the separation between the two masses. The velocity of center of mass is not at all going to change. The velocities of m1 and m2 will keep changing because of this force, but the velocity of center of mass will not change because there is no external force. I repeat, this force F is equal to k upon x cube is an internal force. It is not an external force. It is working between the masses m1 and m2. Okay, now let's come to the question. M2 times small d. So this was your XUM. Now I can write down the value of VCUM, the initial velocity of the center of mass at t equal to t naught, can be written as VCUM is equal to M1 V1 plus M2 V2 whole divided by M1 plus M2. We know that initially M1 was having a velocity V0, whereas M2 was at rest. It means it was having a velocity 0 whole divided by M1 plus M2. I can write down the value of VCUM, the initial velocity of the center of mass. It is equal to M1 upon M1 plus M2 times V0. Write down. Okay. Now the thing is, because there is no external force working on the system, the particle has to move with the same constant velocity, VCUM. This distance, XUM, right? This is the distance XUM. This is the distance XCOM, okay, plus the distance traveled by the center of mass during the time interval t1 minus t0. So L will be equal to simply XUM. X will be equal to XUM plus the velocity of the center of mass multiplied by the time interval, means t1 minus t0. So I hope you would have enjoyed this style of teaching with this digital pen as well as my methodology. So if you want to join my online and live classes, just download my app PHYOMS, PHYOMS. It is available on Google Play Store as well as your Apple Play Store. You can also make me a WhatsApp message or WhatsApp call. Write down my WhatsApp number. It is 9956978830. I repeat, 9956978830. So make me a WhatsApp message or call. We can also use the platform of Skype for the studying purpose. So join me in the journey of learning physics. I'll make you feel the physics. Thank you. Thank you very much.